there are totally 3 attributes which are controlling the light intensity overall. Unlike the exposure, intensity values are linear, and this is the main difference between intensity and exposure. The exposure is 0, and anything which is multiplied by 0 is going to be 0. If you put intensity back to 0 and exposure to any value, you don't get the light. And if you put intensity to a value and exposure to 0, we still get light. If you increase the exposure from, let's say, 9 to 10, the overall light intensity gets doubled when we are adding a value of 8. It is 2 to the power of 8. So I'm going to add the value 512 in here, and we get an exposure value of 9. In the case of our exponent value, our base value is 2 to the power of x. So you can see, if you want to reduce or increase the exposure by 25%, the value in exposure reducing 25% of the exposure. So this is how you can calculate if you want to reduce the exposure by percentage. Hey everyone, welcome back to Swat Studs. I'm here with another exciting tutorial about light exposure and intensity. In this video, we are going to look at the difference between the exposure and intensity attributes in lights. The reason I wanted to do this tutorial is that even though most people use these attributes, most of them doesn't know how exposure actually works and what's the difference between these two attributes, especially why there are two attributes to control the same thing, which is light intensity. So we will look at both of this and how the calculation works in both of them. Is it necessary to use both of them? And importantly, how we can convert the values from intensity to exposure and vice versa. So now let's talk a little about what these terms actually means. And although I'm using Maya and Arnold for this tutorial, what I am showing you here is universal for all the softwares and render engines. So even if you are using another softwares like Blender or Houdini, this tutorial can be useful to you to understand what's the difference between exposure and intensity, which I'm sure is already present in every light in most of the softwares. So exposure is actually a term came from photography. In simple terms, it refers to the total amount of light that reaches the camera sensor. So in other words, we can say it is the overall light present in a scene or in an environment. In photography, we can control the exposure with 3 attributes, which are aperture, shutter speed, and ISO. We can increase or decrease the exposure and make the image brighter or darker, depending upon the look we are after. Most of the time, we aim for the exposure which looks similar to what we see with our own eyes. Making an object brighter is referred to as overexposing, and making it darker is called underexposing. In photography, when we adjust the exposure in camera, we are adjusting the total light present in the scene, whether it's a single light or whether there is multiple lights present. We can also adjust to the exposure of specific lights if needed by adjusting the controls on that specific light. The unit of exposure is called stops. Increasing and decreasing of the exposure is referred in this unit, and an exposure is an exponential value. So what is an exponential value? We'll talk more about when we look at a practical example in a Maya scene. So let's look at the other attribute, which is intensity. The intensity is pretty much directly referring to the intensity or the brightness of the light. In real world, intensity is measured in lumen or watts. That has no relation to the light intensity attribute in the 3D software, because putting a value of 50 in the light intensity in a 3D software won't mimic the intensity of 50 watt or 50 lumen in the real world. The measurement can be different depending upon which light we use and the light size or any other attributes of the light. Unlike the exposure, intensity values are linear, and this is the main difference between intensity and exposure, which we are going to look at in this tutorial. So we'll look at the conversion between the intensity and exposure and how we can use both of these attributes smartly. So let's open up a Maya scene and see what it actually means and how we can understand it better and use it more wisely. So I have this simple scene here in Maya, and currently I have set it up a simple scene with an object with the background and then a sky dome light and an area light. So before going into explaining about light intensity and exposure, I would like to explain to you that there are totally 3 attributes which are controlling the light intensity overall. And we have talked about the first one, which is light intensity, and the second one, which is exposure. But the third attribute is the color itself, because if you click on the color, you can see 3 attributes: H, S, and V. If you change the HSV to RGB, you can see you have a value which is 0 to 1. So let's see if I increase the value 1 to 2, and let me save this render and re-render now. And you can see the light intensity has increased. So if I come back to the color again and change the type from HSV to RGB 0 to 1, you can see all the red, green, and blue channels have the same value here. So in another way, if you are, let's say, adding a texture onto the color, the light intensity or the pixel values on that particular texture will also affect the intensity of the light. So let's say I am going to add a ramp into the light color, and I'm going to just say, let's say, adding a red and then another color, just green. So you are getting a mix of these colors. And if I adjust the intensity, you can see our light intensity also reduces and increases with this. So usually we don't adjust the light color more than 1. Let me just break this connection and make it the default value of 1. Usually we don't add a value more than 1 when it is a flat color. And if you're adding any high dynamic range textures which you have extracted from any HDRI, then you can prefer to keep the pixel values less than 1, or you can use the actual high dynamic range values in the color. We don't need to change that. But if you are using only flat colors in the image, I would say you should keep the value to be 1 and adjust the intensity with the intensity or the exposure attribute. So let's come back to the light intensity, and currently the light we are receiving is only from the dome light. Now let's see how the light intensity works with these 3 attributes. So the calculation which happens in the light intensity is like the color value, which will be the value here, multiplied by the intensity and then multiplied by the exposure. So now you would be thinking that the exposure is 0 and anything which is multiplied by 0 is going to be 0. So actually the light should be 0. But if I increase the light intensity, let's say to a value of 512, you are still getting the light. And why is that? Let's just put the intensity back to 1 and the exposure, let's say 9. We are getting similar kind of intensity. But when I change the intensity back to 0, the light is completely gone. So what is actually the difference when we are putting 0 in exposure and putting 0 in intensity? What is happening actually which is different with the, we are adding the same value in both of these attributes and the light reacts, or the light intensity reacts to it differently? So what is the actual reason? I'll tell you this. So the intensity value is to be, like I said, is a linear value, which means if I put a value of 1, the light value is 1, and if I add value of 2, it adds 1 unit of intensity to the light intensity, and if I put 3 here, it again adds 1 unit of intensity. But in the case of exposure, it's not 1 unit of light which is getting added. If you increase the exposure from, let's say, 9 to 10, the overall light intensity, which was at the exposure value of 9, gets doubled when it is increased by 1 stop. Similarly, if I decrease this from 9 to 8, the exposure value decreases by half. So the overall light reduces to half when you decrease the exposure value. This is because the exposure value is an exponent value, which means the value we are adding here, like the intensity, when you are adding an intensity value of, let's say, 100, the actual value we are adding is 100, but in the exposure, that calculation is a bit different. When we are adding a value of 8, it's not actually an exposure value of 8 which is getting added. It is 2 to the power of 8, which means that this is the number of times the light gets doubled. So in calculation, the exponent is denoted as 2 and to the power of 8. So in exponential values, there is a base value. In this case, because the light is getting doubled, we can say it is getting multiplied by a value of 2. Every time we are increasing an exposure by one stop, it is getting multiplied by a value of 2. So in the exponential value, the base value is 2, and this is the number we are adding as an exposure value is the exponent value, which is the number of times 2 is getting multiplied. So if I am putting an exposure value of 8, which means that the number 2 is getting multiplied 8 times, and that will be the actual value which is equal to the intensity. So this is how we should convert this value from intensity to exposure and exposure to intensity. So let me just show you exactly what's happening here. So in order to get a clear idea, let me just keep only one light present in the scene, and let me put the exposure back to 0, and we can begin from the start. So currently there is no lights present, or the present light doesn't have enough intensity to light the object. So let me add a bit of exposure here. So here you can see even with the value of 100, we are getting really less intensity, and I am just crop region rendering this part, which is more flat area, and the light is directly hitting there, so that I can read the RGB values and we can proceed from there with the change in the intensity value. So with a value of 100, you can see we are around 0.11 in the value, and if I put, let's say, 101, you can see it doesn't make much difference. It's still around 0.11. So let me just add 110, and we are able to see, like, with a change of intensity in 10 units, we are getting 0.01 unit increase. So like I said, it is a linear value which increases with a unit of 1, and let's increase it like really high, which, let's say, 512, and let's see how bright it is now. And you can see now the value is around 0.5. So I've already explained this in the loop development tutorials which I've already made. I'll put the link in the description, you can check that. And I have already explained all of these things about exposure and intensity in the other tutorials as well. This is just, I wanted to make a standalone tutorial so that you can easily refer this in the future without any struggle to find it inside longer tutorials. Now let's come back to the exposure. So I have already explained how the exposure works, and let's say you want to convert this intensity into an exposure value. So I have already explained the exposure is a multiplier of 2, which means if I add a value of 8 times 2 is multiplied. That means 2 multiplied by 2 multiplied by 2 till 8 times. So if you want to convert an intensity value, which, let's say, you had to put like around, let's say, 56,000, that kind of a value you had to put in intensity, and you have to use smaller numbers in the light intensity so that it's more flexible to adjust. So in that case, you can use the exposure, and you want to convert this intensity value to exposure. So in the usual mathematics, what you can do is you divide this value by 2 till you get an intensity which is near to 1. So how many times you have divided it by 2 will be the number which you should be added in the exposure. Or a simple thing would be to go to your browser, and then just you can type log to the base of 2 and whatever value you wanted to convert into the exposure. So you will get a value of, let's say, 15.77. So 2 is 15.77 times divided to get the intensity to be 1. That's what it means. So this is how the conversion of intensity to exposure works. So let's go back to a value of 512 which we have put here, and let's do a render, and we will convert this value to exposure after the render, and we will see if it matches properly. So it is 512 here, so I'm going to add the value 512 in here, and we get an exposure value of 9. So let's get the intensity back to 1 and exposure to 9. So you can see, as I am comparing, enabling the previous render and this, you can see there is no such difference. Whatever difference you are seeing is with the denoising. So you can see here there is no such difference in the exposure here. So this is how you convert the intensity to exposure. And now what if you put a value, let's say, let me just move the light a bit back so that we can add another value in the exposure, so that we can try to convert that back to the intensity. So let me just try to add 10, and let's try to convert this number to intensity. So in order to convert the exposure to intensity easily, you can use 2 to the power is this symbol which is in the keyboard, which is in the top of the number 6 in the keyboard, and then you add the exposure number, which is 10. So you will get 1024. So let's just save this render right now, and let's put the exposure back to 0 and put the intensity to whatever we got, and you can see again the intensity is matching perfectly. So this is the concept of intensity and exposure, and this is how you can easily convert intensity to exposure or to exposure to intensity easily. So one other thing that I want to mention here is that we have seen that if you put intensity back to 0 and exposure to any value, you don't get the light, and if you put intensity to a value and exposure to 0, we still get light. So what is the difference? Since exposure is an exponential value, which means whatever value we add here is the exponent of the base value 2 to the power of 0 is, if you try it here, 2 to the power of 0 is a value of 1. Which means whatever is here is going to multiply by a value of 1, which gives the same number. Whereas in intensity, if you put the value of 0, it is a value of 0, and anything which is multiplied by 0 is 0. That's why when we put a 0 value in intensity, we get no light, and when we put the 0 value in the exposure, it doesn't affect the light intensity. So if you are still confused whether to use intensity or exposure or color, I would say if you want to be more flexible with the term exposure and you don't find any difficulty changing the light intensity in terms of exposure, I would say exposure will be the easiest method to change lighting exposure, especially when you are working in a VFX field, because when we are getting the data from the set and all, and the terms they will be using to communicate with will be in terms of photography terms, and in case there is some talks about intensity and exposure things, they will be talking in terms of stops and exposures, which will be more familiar for them. So it will be easier for the communication. And also if you want to, let's say in nodes, the supervisor is saying like, let's turn down the exposure by half or double the exposure. They won't usually say that in terms of this, or they'll maybe say reduce the exposure by 50%. That means reduce the exposure by 1 stop. So it is a simple term. Let's say you are using a value of like 1756 in the intensity. So halving it, you'll have to like go to a calculator to create half of this to make the light 50%. In terms of exposure, if let's say the exposure is 10 and you want to half the light, let's put like 1 stop down and put a value of 9, which is the half the exposure. I forgot to show you the change in the intensity with the exposure. So if the exposure is 9, let's read the exposure value here. It's around 0.248. And if I increase it to 10, I would expect the RGB value to be near 0.49 or near 5. which is what I am getting here. You can see it is exactly the double the amount of light by increasing 1 unit of exposure or 1 stop of exposure. And if I go back to 9, it was around 0.246, and the half of it will be 123. So if I put the exposure to 8, you can see we are really closer to that value. On some of the points we are getting 123, which is what we are expecting. So before ending this tutorial, I thought I would share some of the informations which I missed in between the tutorials when I was sharing some information, some theories about exposure and other things. One of the things that I think I should clarify is that what is the term linear and exponent means. So if we take the case of exponent values, as you know, there is different type of calculations like addition and subtraction, multiplication and division. So exponent is like another kind of calculation where we give a value and it does some kind of calculation. So in addition, if we give two values, we add the values together. In exponent, like I said before, we have a base value and then there is an exponent value. If we get these two information, we can get the calculation and get a result. So in the case of linear versus exponent, there is an input value which we add in the attribute and then we get an output value. In the case of exposure, when we are adding a value of 10, the actual value which we receive after the calculation is 1024. So in here, the input value is one value and the output value is another value, which is not equal. So there is some calculation in between. When it comes to linear, the difference is that what value we are giving is the exact value we are getting as output. So I want to clarify this with another method, which will be a curve. So here, let's assume that if you're familiar with the graph, it's just a way of showing you what I want to show you visually. So let's say we are representing whatever value we are giving in the x-axis, which is the horizontal line. We can see some values here like 1, 2, 3 till 14. The same values you can see on the y-axis, which is the vertical line. So if I say y is equal to, y will be what we get as an output, and x will be the value which we are giving as an input. So in the case of linear, whatever we are giving as x will be equal to y. So the equation will be y is equal to x. So you can see if we give a value of 1, you can see it gives the output of 1, and if it is 2, it gives the output of 2. And if we draw a line on the values we get as output, it will be straight, and this is commonly known as a linear, where input is equal to output. So this is how linear value works. Whatever we are giving is the value we are getting as an output. But in the case of our exponent value, the x is an exponent value. So I have already shown you the calculation. Our base value is 2 to the power of x. So you can see, let's start from 0. If you are giving a value of 0 in the x, the y value is 1, which is 2 raised to 0, which you have seen. And when we are giving input of 1, the output we are getting is 2. And when we are giving an output of 2, we are getting an output of 4. So here, if you see, it's 1, then 2, and then 4, and then on 3, the value is 8. So you can see the difference between 1 unit of input is 1, but the output difference is, first it was 1, then from 1 to the next value, which is 2, is 1, then 2 to the next value 4 is 2, then 4 to 8 is again another 4. So the value is not constant. In the case of linear output, the difference between each output value was a constant, which was 1. So that is the difference between a linear value and an exponent value. And another thing I wanted to clarify is that the calculation of the total light intensity is always the multiplication of color multiplied by the intensity value multiplied by the exposure value. So even if you convert that from one to the another, let's say exposure to intensity and or intensity to exposure, you will have to keep that in mind to get the same output as before conversion, so that your light intensity won't change after that. And the third thing is that I have shown you the conversion from intensity to exposure by a log 2 equation. So I forgot to tell you what that log is. So it is a short form of logarithm, which is another calculation. Just like how for addition you have an opposite, which is subtraction, and for multiplication we have an opposite, which is division. Logarithm is the opposite calculation of exponent. That is why when I showed you how to calculate the exposure from intensity by dividing it by 2, it's difficult when it comes to a higher numbers like millions in the intensity value. So that is why we have a dedicated simplified equation like logarithm. And just like how we are using in the exponent a base value of 2, when we are using a base value of 2 in the exponent, the opposite will be the same base value. That is why we are adding 2 with the logarithm log. So it will calculate on the base value of 2 of the whatever value we are adding inside the parenthesis. So I guess that informations are clear. And one other thing that I think will be a bit confusing for you is that when I showed you the conversions, I just showed you with the numbers which doesn't have any decimal points. So when I showed you the exposure, it was proper numbers like 9 or 10 without any decimal values. So you would be thinking whether it works with the decimal values like 10.5 or 10.257. So it does work. You have to again use the same calculations. So let's say you want to calculate a value like the exponent value of some number which has decimal. It is also will give you a proper result. So this one is a really high value because we are adding an exposure value like 183, which is like very high intense value. Let's reduce it to, let's say, a smaller number. So you will get a proper intensity value here. And then when I mentioned with adjusting the exposures in percentage, let's say if you want to reduce or increase the exposure by 30% or 25%, how would you convert that? So I want to say that there is no direct conversion method from exponential to percentage. So when you want to, let's say you have an exposure of 8 and you want to decrease the exposure by 30%, what you have to do is that you have to convert that exposure value to an intensity value. Let's see, you get this intensity value of 256, then find the 30% of this 256 value, which will be 256 multiplied by 5, which will be 64. And then you have to minus this value from the actual value and we get 192, and then find the logarithm of whatever value we get after reducing the 25%. So 7.58 will be the value in exposure, which is reducing 25% of the exposure. So this is how you can calculate if you want to reduce the exposure by percentage. So I hope this tutorial was helpful. If you have any doubts about anything further, don't hesitate to ask me on the comments. I'll try to answer that. And if you have seen this video this far, I hope you loved it. And before you go, leave something in the comments, which will help the video to get more reach and find more people who will find it helpful. Subscribe to my channel if you haven't done that yet. I still see more than 50% of people who watch my videos are not subscribed. It would be great help to grow my channel and inspire me to make more contents like this. Share with your friends who are also interested in lighting and looked up. I'll see you with another tutorial pretty soon. Till then, bye.